when we are adding and subtracting algebraic fractions, basically the same rules apply as when we are adding and subtracting non-algebraic fractions. So what are those rules? When we're adding fractions, what are the rules that we told you way back in year 9? We need a common denominator. You could have all told me that, right? So this is all about finding common denominators and using factors, okay? So way back when, we decided that we were going to add a half plus 2/7. That meant that the denominator had to have a common multiple from these two. So what is a multiple that's in the 2 times table and the 7 times table, and preferably 14. Good, the lowest one. Because 28 is also one, but we want 14. All right? To get that, we multiplied. So if we multiplied this by 7, then we need to multiply this by 7 too. Ditto over here, we multiplied this by 2. This needs to be multiplied by 2. All right? So you'll often see people writing this. That's how you should have worked it out right back then in year 9 and 10. 10, of course, you've got a calculator. So then once we've given you a calculator, you no longer thought you ever needed to know fractions again. Problem is, you can't add algebraic fractions on your calculator. So you have to know this sort of secret behind adding and subtracting fractions to be able to do ones that have algebra in them. So we might have something like this, all right? This is actually just 3/4 of x plus 2/3 of x. So what could you do? Grab your calculator and go, what is 3/4 plus 2/3, please, Mr. Calculator? I want that many parts of x, all right? You could do that, but it's not going to work forever, so we'll learn how to. So we go through this process again. We're going to multiply these two together and check to see if when we multiply these two together, it's the lowest common multiple. All right? So 3 times 4 is 12, correct? Is there any number less than 12 that 3 and 4 can divide into? No. So we're good. 12 is our lowest common multiple. It goes on the bottom. Then we multiply by a smiley face. So we're going to multiply that one, and we're going to multiply that one. All right? This one's on the top, so it's going to stay on the top. 3 times 3x is 9x plus, because that's the sign in between, 8x. That gives us 17x over 12. Now, if you had put 3/4 plus 2/3 in your calculator, it may have come up with 17 over 12, or it might have come up with 1 and 5 over 12. That's not so nice, and we've got that D over C button to ABC button that will put it back in this form, because it's harder to put the x in the right place if you don't have it as an improper fraction. So all those things you're learning in year 9 about fractions are now coming into play. So that's pretty easy. This is still at the easy stage. So stepping up one more, what if it has more on it? The denominator part is still part of the secret. So we still want to find that lowest common multiple for our denominator. So these two. So what is that going to be? Yes, 10. No problems there. What's the top going to be then? So now we've got more junk on the top. We actually want to multiply out brackets. Watch that negative though. So we've got 5 times 5x plus 1 and minus 2 lots of 3x plus 4. It'll take us a bit longer now to work out what the answer is. The 10 doesn't go away. It is part of your answer, so don't drop it off. That's been one of the major problems. Multiplying it out, we get 25x plus 5 minus 6x. What's the next sign? And that's a bad mistake too. Negative 2 times 4 is minus 8 over 10, which is 25 minus 6 is 19x. 5 minus 8 is negative 3 over 10. All right? Last part. Okay, so now we just don't have a number on the bottom. So now because we don't just have a number on the bottom, we need to understand what is happening to the bottom. Every single case here, we multiplied. We were checking that it was the lowest common multiple. All right? Now we've ended up with factors on the bottom. We're still multiplying, but we leave them as factors. So what we're going to write over here as our denominator is bracket 2x plus 1, bracket, bracket x minus 6. Don't multiply this out. All right? Otherwise, you're going to do something you may have to undo. All right? So leave it like this. Now we need to look at the top line. So we're going to multiply these two. 3x times x minus 6 plus 4 times 2x plus 1. What do we get? All right, we get 3x squared minus 18x plus 8x plus 4. All over still this thing. Okay, these two terms need to be combined. We're now into the merity one. We don't multiply this out because we're not going to cross out the x squareds and things because we don't do that. We need factors to cross them out. All right. So what we'd ideally like to know now is, does this factorize? Multiply, all right, okay. We need to do windows. All right, so a long time ago we did windows. So we take this, we make it 3x squared minus 10x, a visit to windows. We multiply these two, 12x squared. We put the other one in here and we say, is there something that multiplies to 12 and adds to negative 10? No. Correct? I cannot think of something that multiplies to give 12x squared, 6 and 2, 1 and 12, and adds to give negative 10. Neither 6 and 2 and 1 and 12. So therefore that does not factorize. So therefore that is our answer. Should it have factorized? We need to check that, because if there was a factor here that cancelled with one of the factors on the bottom, we'd have to do that step. In this particular case, we don't have to. Right? So we do have to go through that process. Can't factorize. So this is our answer. All right? But we checked with our factorizing to figure out whether that was the case. What would this have been if it had factorized and cancelled out? Could have been close to an excellence, actually. There's just one little thing that was missing, and that is this fraction can't exist if x is equal to negative a half. Why? This fraction can't exist if x is equal to 6. Why? Because the denominator would equal 0. We cannot divide by 0, ever. Right? You will spend your lifetime trying to work out what the answer is, because the division, 3 divided by 0, says how many times can you take 0 away from 3? Away you go. I can take it once, I can take it twice, I can take it 3 times, I can take it 1,000,000 times, I can take it 10 million times. I can continue to take it from the whole rest of my life, and I will still have 3 on the top. You cannot divide by 0. All right? There is no answer. So if these this was negative a half, the bottom would be 0. If x here was 6, the bottom would be 0. So therefore, this whole fraction would not exist. So this fraction would not be the answer if x was either a half or 6. So we say it can't be those two for us to have an answer. Now, they've never really tested whether this is part of your understanding, but who's to say they won't this year? So when you have an algebraic fraction, the bottom of it is not allowed to be 0. You have to say, yep, this is the answer, unless these are these, in which case there is no answer because you're dividing by 0. Right. So